Hey everybody, welcome back. For those of you who didn't watch the fourth video in this series that covered how the electrical system's laid out in the 2013 Tiffin Allegro Open Road, I encourage you to go back and watch it. The intent of this video is to lay out what I intend to do for the future electrical system for this 2013 Tiffin Allegro Open Road with the Epoch and Victron componentry. So it's going to be the same style of video. We're going to go through the AC system first and then the DC and talk about how the system's laid out at a high level. So starting with the AC, starting at the pedestal, you come in and you go into the south wire surge guard just like we did before. No changes are going to be made there. But after it comes out of the surge guard, that's where this changes start to happen. If you remember, that used to go into the automatic transfer switch. We don't need the automatic transfer switch because the Victron Quattro 2 has that already built in. It has two AC inputs, AC1 and AC2. So the shore power comes into AC2. The generator, the 5500 watt Onan generator, comes into AC1. Again, the default AC input is AC1, just like the transfer switch. And the backup or the secondary is the shore power. So it comes into the Quattro inverter and then out AC1. There's two AC outputs. We're only going to use one in this layout. The other AC2 output I'm not going to cover in this video, but there are two AC outputs. The AC is going to come out of the inverter and come into the breaker box. Now, here's where there's going to be a lot of changes. If you remember, the breaker box before was divided into the main panel and a sub panel. Well, now we just have one main panel. So it comes out of the inverter directly into the breaker box. And the way we could do that is because I got rid of so many breakers from the passing back and forth between the 750 watt tripwire surge inverter that I used to have. I don't need that anymore. So I took those two breakers out and I split one of them. So I got basically shrunk it by 3 breakers, and then I got it into one panel. So that was a big change in this breaker box. So I think that covers basically all of the alternating current into this system. Not a lot of changes. I do want to make one point before we cover the direct current system. Down below, in this circle, I have future solar panels. I'm not going to cover that in this video, and in fact, this project is going to be. I'm planning to put solar panels, but I'm not going to cover or do it during this project. It's going to be down the road a little bit. So that's the future solar panels. Just like before, I'm going to start with the batteries. In this case, we have two Epoch 460 amp hour batteries, which gives you 11,700 watt hours. It's a lot of power. I'm going to start with the negative terminal first. Coming off the negative terminal, I have a cutoff switch. Now, there's a lot of debate whether you put the cutoff switch on the positive or the negative. After reading back and forth, I've decided to put it on the negative because there's some safety benefits to having it on the negative side, and I thought I'd take advantage of it. If for some reason a wrench or tool gets crossed between the positive and negative, and you did it on the positive side, you could still get a jolt. So I decided to cut it off on the negative side. Coming out of that, you go directly into the Victron 500 amp smart shunt. Now this is the IP165 smart shunt, so it's weatherproof, and I'm going to go through that when we talk about our bench setup, but that's the IP165 smart shunt. Now, it's very important that nothing comes before that connection to the smart shunt. No other connections can come before on the battery on the battery post. Now you can put it on the load side all you want, but not on the battery side. Comes out of the smart shunt and into a bus bar. That bus bar is grounded to the chassis of the RV, the frame of the RV. And then a cable goes directly into the Victron Quattro 2. I want to point out that all the cables coming out of the Victron in between that and the battery are 4-aught cables. So we should have, and these are very close, so I should have very little voltage drop between the inverter and the batteries. And there's also, a lot of current that's flowing back and forth, so I put 4-aught cable. Starting with the positive side now, I want to start with these terminal fuses, 250 amp terminal fuses. The reason we put terminal fuses on there is to protect the cabling. In case there is a surge of current, it'll protect the cabling from burning up. Coming off the positive, it goes directly into the bus bar. And then from that bus bar, comes directly off of that and goes into a 400 amp T-class fuse block. Now, there's one advantage of the Epoch batteries is they actually have a T fuse built into them. So by the time I realized that, I already had purchased this fuse. So this may not be necessary, but I thought it'd be better to have more fuses than not enough. So I left it in the system. And so that goes directly into the inverter. Going back to the bus bar, there's a cable, 4-gauge cable. Now everything is back to 4-gauge cable. Coming off that bus bar goes through a 250 amp fuse and goes directly into the generator for starting power. The second cable that comes off of the bus bar goes from here, from the back of the RV, all the way to the front where the spider controls are. And there's a 250 amp fuse up there. And I'm going to talk about the fuse and unfused sides just like we did before. On the fuse side, on the left-hand side of this, it comes out of that fuse and comes over to the left-hand side of the spider controls. The circuits that are always powered. And then, if you remember, there was what they call a salesman switch between this left side and the right side that connect that fuse. And then the right-hand side goes up and over to the DC fuse box in the back of the RV. So once again, if that salesman switch is turned on, which most of the time it's going to be on, the power passes directly from here through here and up and over to the back fuse panel. If it's turned off, it shuts off all of those circuits and the DC circuits in the RV. I do want to go on the unfused side now and up and over. This is where it changed quite a bit. Coming up and over on the unfused side, you can see we got rid of that 250 amp thermal circuit breaker because we don't need it anymore. That used to go to the inverter. So now that unfused 4-gauge wire comes directly into the coach side of the BIM. This is the battery isolator manager. This BIM replaces the merge solenoid that used to be there. So this is designed for lithium battery systems. And so that 4-gauge wire connects directly to the coach side. On the other side, just like the merge solenoid, there's 2 cables that connect to the chassis side of things. And those 2 cables are one that goes to the chassis battery and one goes to the hydraulic pump that levels the RV and the slide outs. So let's talk a little bit more how this BIM is wired. On the left-hand side is how the merge solenoid operates, the original merge solenoid that we're going to take out. And on the right-hand side is how the new lithium BIM is going to operate. We start off with the board that's in the back of the spider controls. That's exactly the same, and the 4-wire connector, that's exactly the same. But starting from the top down, that wire that comes off that 4-wire connector, we're going to leave that going directly into the board. And in this case, we're not going to use it at all. What I'm going to do is on the spider controls, I'm going to use what they call a fuse tap and put a 5 amp fuse into that control panel. So as soon as you turn the ignition on, I get power here. And then the power comes down here. And then this is something new that I've decided to do. I want to put a cutoff switch in the compartment above the passenger seat of the RV. So essentially, when I am driving down the road and I can see the alternator's charging the batteries, I don't want to overcharge the battery. So what I will probably do is cut this switch off so the BIM doesn't overcharge the battery. The alternators don't overcharge the battery. That's the purpose of me putting in this switch in there. So if it's closed, which it will be 90% of the time, current comes over here, hits the ignition terminal on the BIM, and that will connect the house and battery. I'm going to go through that. There's several scenarios when the house and chassis batteries connect. I'm going to cover this in a second after I cover the wiring diagram. Coming back over here, if you remember on the old system, for the auxiliary start on the dash, the power came out of the board. Well, that power will still come out of the board, but instead of going back to the board, I cut that wire off and I'm going to the signal side of the BIM. I'm going to connect it on the signal side of the BIM. And what that does is as soon as that auxiliary switch is pushed, it'll connect the chassis and the house battery connect together. So that's how it's going to be wired. Let me talk about the three scenarios that this lithium BIM has. The first scenario is if the chassis battery is greater than 13.4 volts. Again, chassis battery greater than 13.4 volts and the house is less than 13.3. That BIM is going to connect. And again, the ignition has to be on. You have to be driving down the road. The ignition has to be on. That BIM will, if that two scenarios are met, the BIM will connect the chassis and the house batteries, and the alternator will charge the house batteries. And it'll do that for 15 minutes and then disconnect for 20, allowing that alternator to cool off. Then it's going to reevaluate these voltages, and if the same voltages are present or same criteria are there, it'll reconnect the house and the chassis. And it'll do that until the house batteries come up to voltage. So that's scenario number one. Scenario number two is when the chassis battery is less than 12.5 volts and the house batteries are greater than 13.5 volts. This is a scenario when you're essentially sitting in storage and you want to trickle charge your chassis battery. So it'll connect the batteries for 1 hour if those two conditions are met. It'll connect the house and the chassis batteries. And the third one is if the auxiliary button is pressed on the dashboard, it'll immediately connect the house and chassis batteries. So that's the new merged solenoid scenarios. Going back to the full system layout, that's essentially the DC system. I think I mentioned there's one more thing. There's a 125 amp fuse that is on the terminal, a terminal fuse that's on the chassis battery. I'm going to go ahead and add that so that we can protect the cable that goes back to the BIM. Other than that, that is the entire DC electrical system. That's how I plan to lay it out. I think the next, I'm going through a lot of bench testing right now with the new Victron components, and I think that's what I'm going to do next is talk about how the new system operates on the bench. I don't want to install all this and then have something not work. So I'm going to install it on the bench, test it, set it up, make sure everything works correctly. And so what I'm going to do next video is I'm going to take you through that. I appreciate everybody joining. Thanks. Bye.